Example 2. Solve the inequality. 3x squared minus 5x minus 2 over x squared minus 9. I'm going to make it greater than or equal to 0 this time. So this is almost the same problem. Except f of x is greater than or equal to 0. So we can use the same sign chart without doing extra work here. Actually, let me move this down below here so it's a little more continuity is preserved. So I'm going to snatch up this sign chart, duplicate, move it on down here. Now, this is the sign chart for f of x equals 3x squared minus 5x minus 2 over x squared minus 9. But this time, we want f of x greater than or equal to 0, according to this inequality here. So that means this time we don't want the negative intervals. This time, we want the intervals where it's positive or greater than 0. i.e., we want the intervals where f of x is positive and the values of x for which f of x equals 0. So that's important. So we want those intervals, but we also have the points on the graph where the function is equal to 0. Now, remember that a function equals 0 if and only if the numerator equals 0. So we actually want this point here, that's where it's equal to 0. This point here, that's where it's equal to 0. But we don't want 3 and we don't want negative 3. Because those turn out to be those vertical asymptotes. If we look back at our graph here, this was a 0 and this was a 0. These were vertical asymptotes, and the function's actually tending towards positive or negative infinity at those locations. So, oops, down here. We want the interval negative infinity to negative 3, union negative 1/3 to 2, union 3 to infinity. That's when f of x is greater than 0, and we want x to be negative 1/3 or 2. That's when f of x equals 0. So we want to include these endpoints. So our answer is actually x is an element of negative infinity up to negative 3, not including negative 3, because f of negative 3 isn't 0, f of negative 3 is undefined. Union, we do want to include negative 1/3. We do want to include 2, because those actually make the function equal to 0. And then we don't want to include 3, but we want 3 up to infinity. And this is our final answer for this problem. When is it greater than or equal to 0? So it's based off the same sign chart. It just so happens that I had to choose a couple of values where it was equal to 0, and then I had to choose the other intervals where everything was positive.